Okay, I think now is a good time to get started. So welcome everybody to our third webinar in the Ready, Set, Roman training series. This training series is being put on by the Science Support Center at SSC, at IPAC, as well as the Science Operations Center, the SOC at Space Telescope Science Institute. I'm Tiffany Meshcott. I'm the Community Engagement Lead for the SSC, and I'm excited to welcome you all today to an exciting presentation about the Astronomer's Proposal Tool, or APT, by Annalisa Calamita from the SOC. And just a note about logistics, if you want to ask questions during the presentations, you can post them in the chat, and I will either read them out during the presentation if it's something really pressing, or I'll wait until the end. Next slide, please. Thank you. So this is the schedule of our presentations for the Ready, Set, Roman training series, which we feel will help you prepare and get ready for the Cycle 1 call for proposals. We've already had two webinars, one about the core defined surveys and one about the simulations and how to access the simulated data sets for Roman. And all our slides and video recordings are available on the outer space page that you see here on the left. They're also on our YouTube page, which is at Nancy Roman Sci, which I'll post in the chat afterwards. And you can also join our mailing list to stay up to date. Please do join our mailing list if you haven't yet. This is the best way to be updated about upcoming webinars and when the webinars have gone public on our YouTube page as well. Okay, thank you. Next slide. Okay. Here's a question I'm sure you're all wondering about. When will the Cycle 1 call for proposals be opened? As you know, the release of the call was delayed due to the government shutdown. Now the government is reopened, which is great, but we don't have an official new release date yet. Everyone is working very hard to get a new date chosen, and we will share that date publicly as soon as it's finalized. In the meantime, you can check out the Roman Telescope Proposal System, RTPS, the website here at the bottom, which you'll need to use to submit your proposals. You can also follow the QR code. And if you have any questions, you can always ask the Roman Help Desk. Okay, thank you. Next slide. Okay, so this is my last intro slide. And just before we move on to the APT presentation, just one more slide. Oh, sorry, can someone mute? Thank you. Thank you. So just before we move on to the APT presentation, I just have one more slide about the kinds of proposals that will be in the call for proposals, as this is relevant to how you will use APT. So of course, all the official details will be in the call for proposals once it's released. But in the meantime, here's what we can share with you. So the solicitation will be for analysis, observing, and theory proposals. And all Roman data will have no proprietary period, as we discussed earlier, which means that anyone can access the data as soon as it's available in the archive. And investigators are encouraged to submit proposals for funding to analyze the Roman WFI data from the community-defined surveys. There will also be a small number of new observing programs expected to be selected. And all the details about this will be in the call. So the presentation today is about APT, and APT will be very useful for defining new observations, and it will also be useful to understand the community-defined surveys for writing proposals for funding to analyze those data as well. Which funding sentence? Which one? The proposals for funding to analyze? The second point. Yes, so the question is a little bit more detail on this. Okay, so as I already mentioned, there's no proprietary period, which means that all the data, once it reaches the archive, is public to the community. And what this is saying is that you can apply, so just from the first sentence as well, you can apply for analysis, observing, and theory proposals. And you can apply for funding to do those type of proposals. So that's basically what's explained in the second sentence. For more details on that, you can look at the call when it's released, which will hopefully be soon, and we'll know much more about that soon. Okay, I will hand it over now to Annalisa to tell us more about APT.
Thank you, Tiffany, for the nice introduction. I'm Annalisa Calamida, and I work in the Raman Operations Center at the Space Telescope Science Institute. I'm a scientist there. And today I will talk about the Astronomer Proposal Tool for Raman. I'm sure that many of you already use this tool to submit your observation for the James Webb Space Telescope and also for Hubble Space Telescope. But there are some very new features for Raman, because Raman telescope will operate in a different way in comparison to these two previous missions. In particular, Raman is a survey telescope. So we had to change APT according to this. So I will briefly introduce the Astronomer Proposal Tool. Then I will show you how to retrieve some example programs, which will be very useful to understand how the survey observation are being organized, but also as an example on how you can prepare your observations. And then I will show you step by step how to create your own observing program in APT, and how to run the visit planner to see if the observations are schedulable, and save the APT program. So the Astronomer Proposal Tool has been developed for Raman. In particular, now we are at version 2025-6.3, and you can download it from the APT website, Space Telescope. You can use the QR code to reach that website. APT is used to create observing programs for Raman and to, as Tiffany said, also to see how the survey observations are being prepared. And as new functionality specific to Raman, I will talk about this later. And it's very important to create your observing program well in APT, because some of the parameters that you specify here, then they will be used for the data processing by the Raman pipeline. Okay, so on the left here, you see a list of new features developed for Raman in APT. And on the right, you see a schema of how you create your observation in APT for Raman. One of the new features is the possibility to create region targets. So Raman is a survey telescope, and we need to serve big areas of the sky. So this feature gives you the opportunity to create a polygon of whatever shape by defining its vertices, and to survey a region that you are interested in. While the mosaic tool allows you to create a mosaic of different shape as well. And then the segment plan is the basic unit of your observations, and you have multiple segment plans that go, or even one, that go in a path plan. And then we have the tool called survey plan, where you create and plan your observation. You create different steps, which are called survey steps. So looking at the schema on the right, to specify your observation, you need to insert a target, which can be a fixed target, like you were doing before for James Webb and for Hubble, or you create a region to be observed, a region target. Then you need to specify, or it's not mandatory, but it's better to specify a dithering pattern, like you were doing before, again, for JWST and HST, and you can specify a mosaic pattern. This information goes in when you create your observation specification on APT, and then you create your segments that are included in your path plan. Then you are ready to create your survey plan with multiple survey steps. And in this phase in particular is where you can specify special requirements, which could be a particular position angle that you want to use for your observation, or it could be linking requirements. For instance, you want to do time series, and so you need to specify the period and how you want to do this time series. This is an outline of that I will follow to create the APT program. First of all, I will load a demo program and show you what you can learn from this. And then I will start creating my own Roman program by using a fixed target and also creating a region target. In this case, the target will be a galactic globular cluster 47 TAC, and the region will be a big sky area around this cluster. I will also show you how to create a mosaic pattern and what you can do in different ways you can create it, and how to build your path plan to do different things, and how you can visualize this the region that you want to serve on Aladdin. And then I will show you how to build your survey plan. And you can also, in the survey plan, you can also add like how many times you want to repeat your observation. And again, as I said, you can have special requirements and timing requirements. And then we will run together the visit planner to be sure that our survey plan or the different survey steps of the survey plan are schedulable.
Annalisa?
Yes.
There's a question in the chat that might be relevant to answer now. It's, what is a pass plan? And is that a specific observing mode?
No, it's not a specific observing mode, but is the step that you need to specify your observation. And I will show it. It's easier to understand when I show it on APT later. When we are done, we will save the APT file, and this will be later submitted to the Roman Telescope Proposal System managed by the Science Support Center. When the program is approved, then you will be able to use APT to submit it also to the SOC Space Telescope, and you will be able to visualize the execution plan on APT as well. If you need more information about Roman APT, you can consult the Roman APT user guide at this website, and there's the QR code. Or if you have questions, you can contact the Roman help desk at this webpage, and again, the QR code. Can you still see my screen?
Yes, we can. Thanks.
Okay, now this is APT for Roman. So I was saying version 2025.6.3. And I have a Mac computer. So for me, the menu is here on the top of the screen. And if I click on File, as you can see, I have Roman demonstration program. So there's a list of some programs that show you how to perform imaging and spectroscopy on globular cluster or galaxies. And there are 4 demo programs here, which 3 of them are for the 3 core community survey of Roman: the Galactic Bulge Time Domain Survey, Highlighted Time Domain Survey, and Highlighted Wide Area Survey. And then there is the Galactic Plane Survey here. So you can open any of this program to see how the observation have been devised. In this case, let's open the Galactic Bulge Time Domain Survey, since it's the program for which I worked the most. Here we go. So this is a reminder that this is not the entire survey, but this is the phase 2 for a mini version of the survey, because otherwise it will be too big here. So we have program information, the title, and the very short abstract describing what the survey is going to do. And as I was talking about, this is the new feature, mosaic pattern, where you can be differentiate custom mosaic. And in this case, the Galactic Bulge Time Domain Survey is observing towards the galactic center. So this one is the galactic center field. It's a total of 6 fields to do time series for microlensing to detect exoplanet. And the bulge is visible for about 70 days in 2 seasons, spring and autumn, but it's flipped by 180 degrees. So it was needed to build 2 different mosaic, one for the spring observation, one for the autumn observation. And again, for the question, these are the different path plan, and they define your observation according to what you have to do. This is for the spring, the snapshot observations. So it's imaging in multiple filters. In particular, we take more observation in the Y filter for this survey, the 146, but there are also other filters you can see here. And here at the bottom, you can see how many visits you have in this pass and how many observations, 110, okay? So the other thing that you can do, you can hover with your mouse on the blue writings here. And if you see a question mark, you can click on it, for instance here. And your browser will open the documentation page regarding that item, in this case, observation per segment, okay? Then we go back to the proposal tool here. And we keep going. This is one full season of the Galactic Bulge Time Domain Survey. Here we go. So it's multiple, as you can see, observations in one filter for the time series with snapshot into other filters. And then we have our survey plan, which is composed of different survey steps. I click on survey plan here, and you can see the list of the different steps. So the snapshot observation, the time series observation, which include a total of 47,424 visits. Okay, let's go back here 2 seconds and I want to show you something. Here I have a total of 52 observations, right? But then this item that was empty before here, God, this thing. It says now 152. So I have 152 segments in this pass. And so I have a total of, I multiply for the number of visits, and I have a total of 47,424 visits here, reported also here. Okay, this number here. And here you can see the science time required to do these observations, which doesn't include any overheads. You can see the execution time, which includes some of the overheads. And then you can see the charge time, which includes all the overheads, including the slew times, okay, in hours. All of this number expressed in hours. But now let's close this program. Or Aladdin goes crazy. Just close it. We don't want to make any changes. Great. And let's start creating our own program. I go here again on File, New, Roman Proposal. Here we go. So as you can see, the title and abstract field, they cannot be filled because this will be submitted directly on the web page of the Roman Telescope Proposal System when you submit your proposal. Then we start with targets. As I was saying, there are the usual ways to add targets as we added for JWC and HST. And then we have the new feature for Raman where we can create a new region target. I want to add, first of all, my global cluster by using the target resolver because it's a very famous one, so it should be there. And it is in an NGC 104, and I add it, okay? Then I have a red cross here because I need to fill some mandatory fields, which is the category, stellar cluster, and the description, globular star cluster in this case. Now I'm getting a warning because I'm not using this target in the proposal here. If you want a summary of all your errors and warning, you can click on the red cross here. But now I will show you how to create the region target. So I click on New Region Target. Here we go. Let's give it a name. We can call it 47, TAC halo. So I want to serve an area around this cluster to be sure to see if there is a stellar halo or maybe tidal tails around the cluster. And you can do that by manually inserting Ra and Dec of the vertices of the polygon that you want to serve in the sky. But a much easier way to do that is to create your polygon and save in a file the coordinates by using another tool. In this case, I use Aladdin, the standalone version of Aladdin. So I can import the file that I created. It's a CBS file, CSV file. Here we go, 47 TAC halo. As you can see, this is the polygon of the region of the sky I want to set. Every blue rectangle here is a Raman pointing, or tile, as it's called here, okay? And is approximated, obviously, with a rectangle. Then when I click on Apply Plan to Target, I come back here and I get the coordinates of the center of each of these tiles. So I have I need a total of 46 tiles of pointings to cover this region. And here you can see the 46 coordinates of the centers of this tile, okay? I come back here and you can decide to use a different orient to cover this region, say for instance 20 degrees, and then as you can see, the number of tiles that are needed to cover the region will change. It's now 44, okay? Let's go back to 0 now. And there is another function here, which is called mosaic, because I can decide to cover this area by using a mosaic instead of a single Raman pointing. But I didn't create a mosaic yet, which is the next step, so we can come back here later. To create a mosaic, I click on Add, and I have two options. I can use a grid and define like a number of rows and columns that I want for in this mosaic. And again, the Raman pointing is approximated with a rectangle, or I can define my, like it was before for the demo program, it was a custom mosaic. So you can add X and Y in arc minutes, which are the distance from the center of the mosaic. Okay, let's go back now, remove this. Let's go back to the grid. Here you see how big your mosaic is going to be. In this case, the height and width in arc minutes. But I'm observing global cluster, so the center is very crowded. And so I would prefer to cover the center of the cluster with more images. And so I can increase the row overlap and column overlap here. This is expressed in percentage. Let me increase the column overlap here a little bit more. Here we go. And the sides of your mosaic is changes, you can see here, but I have more overlap in the central region. Okay, let's give it a name of this mosaic. I call it 47 tag image, since I want to use it for that. Okay. Still, I get a warning because I'm not using any of these in my path plan, but I'm gonna define a path plan now. So I click on Add. I need to give it a name. In this case, I want to do deep imaging of this cluster. So I call this path plan deep imaging. I need to select my target, which could be the cluster or the region. In this case, it's the cluster. And then I can finally define my observation. How? So I need to decide if I want to do imaging. Here are all available filters, or if I want to do spectroscopy, prism, grism. And in the case of imaging, my multi-account table is called like this, imaging. And then the first number is the total exposure time, in this case 60 seconds. And this is the number of resultant, in this case 6. But if I want to do spectroscopy, I can select grism, and my multi-account table will have a name as SP, and then exposure time again, and the number of resultant. But I want to do imaging in this case, so let's go back to my filter. Let's assume I already did all my calculation with the Raman ATC. So I can put my exposure time. Then I decided to use this mosaic for my imaging. So I selected here. And I would like to cover the gaps in between the detector. So to 100% cover the gaps, I need to use at least a line gap 3, or I can use a box gap. In this case, let me use a line gap 3. And I want to use some sub-pixel dithering to retrieve better my PSF, since this is a very crowded stellar field. Let's use sub 3, for instance. And I want only one exposure per dithering, and I want to repeat the observation once. Here you see the total number of visits, which is 6, because my mosaic is made of 6 different tiles of pointings, right? So I will have 6 visits. So this observation in this segment includes one observation, which is the one that I define, but includes 6 visits. If I want to repeat it twice, I will add 12 visits, okay? Let's go back to 1. The easiest way to add observation in other filters in this past plan is to duplicate this. Just click on duplicate, okay? And then you have to change the filter, change the exposure time accordingly, use the same mosaic, same detail, etc. Can decide to repeat this twice, for instance. So I will have a total of 18 visits and 3 observations in this segment. 2 of them are here. So this is the first one, and this is the second and the third. Okay, 3 observations in total and 18 visits. Then I would like to get some observation on my halo region. So the easiest way to do that is just to duplicate this. Click here. You can also use the function multiple duplicates, but I want to duplicate this only once. Then I go here. I have to change the name. Okay. And of course, I need to change the target. I want to take imaging on my halo region here. I want to use the same filters, but I want to repeat this only once, okay? So I have a total of here 12 visits, but I don't have only one segment because I need 46 pointings to cover the entire region that I defined, right? And so my visits will be 12 times 46. So this past plan includes 552 visits in total, okay? Here we go. When I'm done with my past plan, or I can try to visualize this on Aladdin. Let's see if it works. So let's start from the region. View in Aladdin. Can we see it? No, yeah, not really. Great. Okay, likely I created a slide to show this because I didn't trust it. Okay, so here you see my mosaic. So it's a mosaic 3x2, centered on the cluster with larger overlap in the central region. And then here you see the region with all the 46 tiles. And you can change the opacity of the region. If you want, you can also manually change the orientation here on Aladdin. Okay, and I'm using DSS color image, but you can upload. You have 2MAS and other surveys here. You can choose your favorite survey. Let's go back to APT. Form editor. Okay, and let's start working on the survey plan. Okay, now it's empty. I need to create my survey step, and to do that, I can click on Add, and I can choose one of my past plans, in this case, the deep imaging. I want to repeat it only once. Here is where I can add my special requirements. For instance, let's click on special requirement, and let's select my step, add requirement. And there are different ones. So you can select a specific position angle. V3 is the axis of the telescope. You can specify this for your observation. You can specify that you want the passes not to be interrupted and to be executed one after the other. You can specify this observation is a target opportunity. If it needs to put on hold, you're not really sure you want to start this. Or between is like, you can select a range of dates for when you want to serve your target. Okay, in this case, let's add, sorry, I don't want this one, remove. I want to add an orient constraint, let's say from 0 to 100, okay? And then here in the list of my service step, you can say you need to repeat this once, this one segment, but it includes 18 visits and it has one special requirement. Then let me add another past plan. So my second service step, for the halo imaging. I want to repeat this only once. Okay, I don't want to add any constraint to this. It's 552 visits, as we saw before. But for instance, now I decided that I would like to do time series on my globular cluster. Okay, how do I do that? And there are multiple ways. I'm going to show you a couple of them. One of them is you duplicate this, okay? Then you go here and, sorry, down here, linking requirements, and you add, you say how many times you want to repeat your observation. How many epochs do you want? Okay, let's say I want 6 epochs, okay? Done. Of course, the number of visits and segments is increasing, okay? 6 segments, so 108 visits, okay? Then I can specify linking requirements, add, timing links, time series, okay? So as you can see in this service step, I have 6 passes here, and I want them to be observed with a period of, let's say, 5 days and a tolerance of 1 day. And here you see the summary of what you're doing. So this will be 6 passes spaced over approximately 25 days with a period of approximately 5 days, okay? Click OK. Now you see how many passes are here. It's like from 2 to 7 because it's 6 passes. There's a requirement, which is the orient requirement. And the other way is this one. I got my pass. I duplicate it. Oh, I can do this. It's easier. I can do a multiple duplicate. So I want another 5 of this. Okay, here we go. This first one, and then I have a total of 6. Okay, and then what I do, I go back here and I want to add a linking requirement, add time series again. But in this case, I do something different. So I select my 6 steps, 1, 2, 3, 4, 5, and 6, and I say I want them executed with a cadence of 5 days with a tolerance of 1 day. Okay, which essentially is the same thing I was doing before, but done in a different way. Okay, here we go. And then you have these passes, each is composed by 18 visits, and they have a orient requirement and a timing requirement that you can see here. Okay, so you're doing essentially the same thing, we just define it in a different way. Then let's start running the visit planner. So from Form Editor, I need to go on Visit Planner here. Here we go. Let me select only step 1 at the moment. Let's go back, okay? Because otherwise it takes too much time. Oh. But this is time series, so they are connected. We need to run this at the same time. This is red because we still have to run the Visit Planner. Let's hope it doesn't take too long. Okay, it wasn't so slow. So all my service steps are schedulable. As you can see, I'm doing time series with a different 5 days. So that's what you're seeing here. It's gonna start in this window, starts March 12, this March 17, March 22nd, and so on. And I put, this is when the target was feasible. But since I put orient constraint here, then my schedulability decreases. From this, I got this, okay? If I want more details on how all of this is calculated, you can click on reports here. And you can get some plots. For instance, this is your positioning goal ranges as a function of date. I said that I wanted an angle from 0 to 100. So my observation cannot happen until at least March here, March 12, okay? And you can check this to try to organize your observation and schedule your observations. You can also print this plot and save it. Let's close this. And let's go to Form Editor. And let's go to save the program. I go on File, Save As. I can give it a title. Okay. 2025. And save it, and then I can submit this file with my proposal at the Roman Telescope Proposal System, okay? And now I can get questions.
All right. Thank you so much, Annalisa. That was a great presentation. We had some questions in the chat already, which I think have already been addressed. If anyone who asked a question feels like they want follow-up on it, please go ahead and post again. People are also welcome to raise their hand if they want to ask a question directly, and they can unmute. Carl, yes, you go ahead and unmute. Thank you.
Yeah, okay. Hi, folks. I was just curious for the schedulability. There are a lot of fixed observing blocks for the galactic bulge time domain survey and the other core community surveys. So how do we tell if we're proposing something that can only be scheduled in conflict with a core community survey?
Shall I answer that? Or someone else wants to answer?
I think you can answer it if you, or if there's someone else who would prefer.
This is a matter of policy, but yeah, I mean, here on APT is just detect when your observation for your specific target are schedulable and visible, but it doesn't show you what will be the full observing plan.
Yeah, I
Doesn't
guess
show you,
what
okay, no, you can observe this target here because the galactic bulge will be observed for this in this
Right.
time period. That we don't get this information APT, but I think Charles raised this hand.
Yeah, this is Charles from the SOC. This is a good question, and it's a matter of policy, like Annalisa hinted at. And this will likely be specified in the call for proposals. But from what I understand at this point in time, is that the general investigators that will be submitting programs during the call for proposals should not be concerned about whether they conflict with the CCS or the GPS surveys for now. It will be the project and the SOC's problem, if you will, to try to make it fit in the schedule. So for now, users should not concern themselves whether they have conflicts or expect conflicts.
So I'd like to push back on that because on the Roman coronagraph CPP team, we're planning observations and selecting targets, and we're already depreciating targets that we know can only be observed during the galactic bulge time domain survey. So I think it would be really useful if APT would show the scheduling blocks of the fixed core community survey activities so that we don't discover after we've submitted that, something that's really important to the science proposal just can never be scheduled. The way moon avoidance is handled in APT now, if we could have time domain survey avoidance shown to us too, that would be good in selecting targets.
Yeah, I understand. I think right now this is beyond the capabilities of the APT, but this is certainly something that can be looked at behind the scenes here at the SOC in coordination with the project. But right now, this is not something that we offer. And as I said, like specific directives will come out during the call for proposal regarding schedulability, I expect anyway. So, we'll know more then for sure.
Okay, hope to see it there. Thanks.
Thanks, Carl. Thanks, Charles. Okay, we have a question in the chat from Ilaria, who says, could you show how to draw a region in Aladdin within the APT and then save it to CSV? That was the first step.
Yeah, as I said, I did that with a standalone version of Aladdin. So it's not the Aladdin connected to APT. And to show you, I just created my region and then I just went here and save, and I save it. I just save it as the file that uploaded on APT. No, it's not in the heart of the APT, no.
Okay, thank you. Any other questions? You're welcome to raise your hand or put it in the chat. Oh, there's another question here. If I download APT on my PC, is there any file that I can edit to increase the font size within APT just on my PC to suit my requirements? I will let you answer that, but I suspect there could be some local to your computer ways to make your actual screen larger. But the APT
yeah, for
experts...
this font, yes, but in the case of Aladdin connected to APT, there are some command line that you can use to increase the font size and even the font color. If I'm not mistaken, you have to go on Tool and Script Console here, and then you can use some commands. I can maybe we can post the link later, but you can set things like config, color, and size of the on the font, and then execute, and then this will change here. I don't recall exactly the command I had to write here, but there's a possibility of doing that. Regarding the font here on APT, I'm not sure, but again, for sure you can increase the font in your computer.
Thanks. Yeah, that's a good question. Any other questions from anyone? Again, you're welcome to raise your hand or post in the chat. Give it one more minute. See if anyone else has any other questions. Okay, I think we'll call it there. So thank you so much, Annalisa, for a very clear and helpful presentation about APT. If anyone does have follow-up questions, you can always post them on the Roman Help Desk. And be sure to check out our outer space page for updated information about this and all of our previous and future webinars. And there you can find the link to our YouTube as well for all the recordings. Oh, I'm sorry, there is one last question. Is it necessary to have tile number and number of passes same?
Can you hear me?
Now we can hear you.
Yeah. To have tile number and number, no, they don't need to be the same. No, I mean, let me share the screen again. So you said passes equal tile? Sorry.
The question is it necessary to have the number of tile and passes the same?
Are you referring to, probably you're referring to this, the region target? Yeah, this is okay, maybe I understand now. So this number is not edible, as you can see. It's calculated directly because you require this number of segments to cover all your region, because your region is done by 46 tiles. Here, you can actually edit this. Okay.
In the follow-up, they say, in the example, you selected 6 tiles and then gave 6 passes.
this, okay, 6 visits because my mosaic has 6 tiles. Yeah, this calculated is not something that you fill in. You can decide to change this, edit this, you can change the number of exposure, but you cannot change the number here. This number here is calculated. It's not editable because it's in gray, as you can see. These are numbers calculated by APT. And I didn't show you this, but I can. So you can decide, instead of using, as I was saying, the single Raman pointing to cover the region, you can actually decide to use the mosaic. So now the tile are only 14 because each tile has actually 6 Raman pointings. And the other feature here, by looking at this nice plot, you can say, okay, I don't really need this, okay? Because this is not an area of the sky I'm interested in, or this one. So at that point, you can go here on your region information, say, I want to remove that tile. I think it's this one, I'm not sure. But let's say that it's this one, then I say remove, okay? Then you go back and you don't have it anymore, okay? And same you can do with this one, you can decide to remove the regions that are not really useful because they're here, because there is a small corner, but then you're not interested in this area really, so you can remove this. You cannot do it directly from the plot. You can do that when you are visualizing the mosaic. You can, I didn't show you this, see? I can decide to remove this. I want to do a mosaic with a different shape and focus on the center of my object, so I can remove this tile or disable them. So number of disabled tiles is number 1 and number 4, okay? Then I can put that back. But in the case of the region target, I cannot do directly this from the plot, but I need to do it from here. I can remove any of the tiles. Okay, now there are more questions. So.
Carrie, you raised your hand?
Yes, can you hear me?
Yes.
I just wanted to circle back a little bit to the point about the overlap with the core community surveys and the GIS programs. Sorry, I couldn't get quite set up fast enough. So Carl, you raise a really good point. However, we did have discussions about showing the conflicts in APT, and it's actually a considered choice because the GIS programs are intended to have to not be secondary. They're intended to kind of be on the same level as the core community survey programs. And most of the core community survey program observations are kind of movable depending on what GIS programs get submitted. The galactic bulge survey, as you mentioned, though, does have very tight restrictions. It is taking the majority of the availability windows on its high cadence seasons, but those aren't all the seasons. And so, a program that wanted to observe those could be done in one of their low cadence seasons where there's a lot more opportunity. That said, if someone really wants to observe the galactic bulge and it's really important to do it in like the first few seasons, depending on where exactly you're pointing, that changes the availability. So you could open up the core community survey APT program and look at the visit planner and where those observations can be taken, and that would give you an idea of where you need to look has any windows that it could, that don't land right on top of the availability windows for the galactic bulge time domain survey.
Yeah, okay, thanks for mentioning that. I mean, on the Roman CPP, we're currently making our not very well-founded guesses as to where the conflicts with the bulge are. So being able to see specifically in the way you suggested will be helpful to us.
Yeah.
And it's also good that, as you say, maybe some of the other surveys, not the bulge, could be slid around a little bit because of equal priority for these things. So I think that helps. And if maybe the only APT request I would make would still be to show the bulge scheduled observations.
I mean, well, so, and that's part of the thing is they're not like actually scheduled yet, right?
Mhm.
The final schedule will be made once we have all the programs. But Charles and Annalisa, correct me if I'm wrong about being able to open up the galactic bulge and see the survey and see that.
This is Charles again. The final programs are not in just yet. We do have demo programs, but again, they're not the full versions. So that does not provide you with the full picture, unfortunately. We are still working on the flight programs, and they will be made public whenever, as soon as we can have finalized.
Yeah. So once those are public, you'll be able to do what Annalisa is doing.
Is that
Yeah.
you're likely to be February or March?
Yeah, this is assuming that the telescope will be launched next fall, right? And there will be commissioning. And so, yes, this is when these targets, the galactic bulge, right, is visible, and the constraint on the timing, the time series, as you can see here. And so you can already do that, but we don't know the final schedule until, you know, we actually launch the telescope, you know, and we do the commissioning. Yeah.
Okay, thank you. Anyone else? Final questions? I think we may have covered everything. Again, you can always submit to the Roman Help Desk if you have follow-up questions after this. Thank you again, Annalisa, for a great presentation. Thank you, everyone, for joining and for contributing questions. And remember to check our outer space page to see the recording from this and previous webinars, and you'll see dates about future webinars. And we'll send an email later this week with the details about the timing of the next webinar. And so thanks, everyone. Have a great rest of your day. Thank you.
Thank you. Bye.